Now if we look at s of t equals the square root of t squared minus 3t, then we see that the first thing we're going to evaluate, if we given a value of t, is t squared minus 3t, and then we're going to take the square root. So this is a composite, and it's pretty obvious how the composite breaks down. Now I've got s of z, and I've got some z's in here I really want to use u's, so I'm going to go off screen for a second, modify that. Okay, so if s of u equals square root of u, and g of t equals t squared minus 3t, then s of g of t equals, well, s of u is the square root of u, so if g of t replaces u, then it replaces u here. We get the square root of g of t, and that's, of course, then the square root of t squared minus 3. Now, if we wanted to take the derivative, I'll kind of insert that around here. We can see that if s of u equals u, then s prime of u equals 1 over 2 times the square root of u. And if g of t equals t squared minus 3t, g prime of t equals 2t minus 3, so that s prime of g of t, s of g of t prime equals what? It equals s prime, and it's supposed to be g prime. By the magic of the pause button, now it is g prime of t times s prime of g of t. Now the function is s now rather than f, but that's okay. Okay, so what's g prime of t? That's your 2t minus 3. And what's your s prime of g of t? Well, it's 1 over 2 times the square root of s prime of u is 1 over 2 times the square root of u. So s prime of g of t is 1 over 2 times g of t, 2 times the square root of g of t, but g of t is 2t minus 3. So we have 1 over 2 square root of 2t minus t squared minus 3t. Okay, the g of t function. So you might not have might be a little hard to read. It's 2t minus 3 from the derivative of g of t, and then 1 over 2 square root of u becomes 1 over 2 square root of g of t, and g of t is t squared minus 3t, so we have 1 over 2 square root of t squared minus 3t, and that's exactly what we have here. Okay, so that's how we would apply the rule in this case. Now I'm going to do another example, and I'm going to use the sine and cosine functions. Now you don't have to understand the sine and cosine functions. All you have to understand is the rules I'm giving you for the derivatives of the sine and cosine function. And you don't have to know these rules. We're just going to use them now to illustrate one more example of how you can apply the chain rule. And I like the sine and cosine functions as illustrations of the chain rule, because the chain is more obvious in this case. Just as the chain was more obvious when we had the square root of t squared minus 3t than it would be, than it was if we had 1 over x squared minus 3x. Okay, now this is the reciprocal of x squared minus 3x. This is a composite then of the reciprocal function and the x squared minus 3x function, but it's not as obvious as it is that this is the composite of square root and t squared minus 3t, and the example we're going to do with the sine. Okay, so the derivative of sine of x with respect to x is just cosine of x, and just for, we're not going to use it, but the derivative of cosine of x is negative sine of x. Now, if we have the function f of x equals sine of 3x minus 4 all divided by x squared, then what's the breakdown? Okay, the breakdown is pretty obvious. F of u is going to be what? Well, it's going to be the outer function, if you prefer, the sine function, the function that's applied to the other function, because f gets applied to whatever the u function is. Okay, so f is going to get applied to 3x minus 4 over x, to the sine function, and then that's going to be applied to the 3x minus 4 divided by x squared. So f of u, in any case, is the sine of u. And then your g of x is what? Well, g of x is what that sine applies to. That's your 3x minus 4 over x squared. So, if f of u is sine of u, we want f prime of u, because the chain rule is going to say we want f prime of x equals g prime of x equals f prime of g of x. We're going to need g prime of x. Now I'm going to delay, I'm not actually going to take the derivative of that, but g prime of x is going to be the derivative of this, and you would calculate that derivative one of two ways. You could use the quotient rule, or you could break this into two power functions, the difference of two power functions. Be easy enough to take the derivative of your g of x function. I want to illustrate the chain rule, though, and so I'm going to leave this as g prime of x for the moment. And then we want to see what this f prime of g of x is. Again, f prime of u is cosine of u. So f prime of g of x will be cosine of g of x. And of course, cosine of g of x means a cosine of 3x minus 4 over x squared. So we have a cosine of 3x minus 4 over x squared. That 3x minus 4 over x squared doesn't change between here and here. Just like up here, the t squared minus 3t didn't change between here and here. Now we did take its derivative here, but in this term it did not change. Okay, so by applying the chain rule, we get g prime of x times the cosine of 3x minus 4 over x squared. I'm out of room over there, but I came back over here and wrote out that we're going to have what? 3x minus 4 over x squared. That's what g of x is, so it's that prime times the cosine of 3x minus 4 over x squared. And hopefully that makes a little bit of sense. But the way to do these derivatives is to do a lot of them and do a lot of practice and apply the rule very carefully.